lines. So when the gradients of two lines are not equal, they must intersect, isn't it? If the gradients are equal, they're parallel, they never intersect. So to find the coordinates of the point of intersection, we need to find the equation of the line, then solve the equation simultaneously, which you will learn in chapter 3. All right, let's do question 30. Find the point of intersection of these two lines. So what do you do? You solve them simultaneously. So let's call this number 1, call the second equation number 2. And you're going to solve them. Now, hopefully remember the techniques to solve this equation. What do you do? Do you add them? Do you subtract them? Or do you make y the subject? What do you do? There's many, many ways. Elimination will be the fastest. Yes, where x and y are both on one side of the equation, it's faster to eliminate. So how would you eliminate? What would you suggest? Add them. Let's do that. 1 plus 2, what do you get? X plus x is 2x. What happened to the y? They get cancelled, right? Y plus negative y is 0. 5 plus 3 is 8, so therefore x is 4. Very quick and easy. Now, once you found the x value, what do? You say again? No, not plot the point. Substitute back either 1 or 2. Let's put it into 1. So from 1, you get x plus y equal to 5, but x being 4, so what's y equal to? Y must be 1. So now write down your answer as a point of intersection. So I'm going to use a shorthand. POI, point of intersection, is 4, 1. Yep. Okay, all done? Excellent, good. All right, we'll do the second part once you're ready. Yep, concurrent. Now, there's two words. Remember what collinear means? Yeah, when the points on same line. Concurrent means all lines on the same point. To pass through the same point, that's pass through the same line. Does that make sense? So they both have a code there. Concurrent means lines pass through the same point. That's called concurrent. Let me write it down. Concurrent means lines through the same point. Okay, good. Now, notice, what do you notice about part B and part A? What do you notice? Is that the two lines are the same, right? So already we found where these two lines intersect. Where do they intersect? They intersect on 4, 1. So to show that they are concurrent, you have to make sure this line also passes through this point. Now, does this line pass through this point? How do I know that? How do I check it? Sub it in. Very good. So we're going to substitute 4, 1 into the third equation, which call this number 3. So you get 2x minus 3y equal to 5. And then you substitute. So now remember how to check. You go left-hand side equal to 2x minus 3y. And replace x and y by 4 and 1 respectively. So x equal to 4, y equal to 1. Let's work out 8 minus 3. What's 8 minus 3? Yep, is that the right side? It is. So what can you conclude? Yeah, they all pass through the same point, 4, 1, right? So the three lines are concurrent. Yes, concurrent. The three lines are concurrent because they all pass through the same point, 4, 1. Because they all pass through the same point. And what's the point? 4, 1. I don't have to, but just give you. So it's enough. I think it's enough if you just say a conclusion. But I'll just put it there so that you know why they are concurrent. Because they pass through the same point, 4, 1. Okay, so do you know how it works now? Excellent. Thank you. All right, that's good. First page done successfully. No problem. Then we'll do the next bit, which is a little bit more abstract, but you'll get it at the end. Yeah, we are. Yes. All right. So we're going to continue. All right. Okay, all got it? Next page. Yep. All right. Thank you. Now we're going to look at family of lines through the intersection of two lines. Oh, that's why you say family. Oh, okay. Now, why is a family? We all pass through the same point. Now, let's do an investigation. So when we learn maths, we learn through investigation. We're going to consider two lines, x equal to 2, y equal to x. Now, guess which one's x equal to 2? The vertical line. The red line is y equal to x. Let's label them. So this is y equal to x. This is x equal to 2. Okay. All right, good. So sort of you can see where they cross. They cross at the point 2, 2, isn't it? Right? They have a point intersection over here. Okay, which is mark that point. Now, before we continue, we're going to write both equations in general form. Hopefully you know what it is. What's a general form? General form looks like ax plus by plus c equal to 0, where all terms are on the left side and there's no fraction and the coefficient of x is positive. So what would that be? X equal to 2 in general form be? What would that look like? Well done. Yeah, it just doesn't have a y term, so it's in general form. And also I wanted to write this thing in general form. What would that be? X minus y, yeah, because we want to keep the x term positive, right? It's always to have a first term positive because it looks better. Okay, so we've got two equations that are in general form. Not really, but then it's better not to make a negative. Yeah, okay, it looks better. All right, let's write a new equation. Now, hopefully it doesn't confuse you. We're going to combine equation, right? We want to put it into a family, right? So in a family, so we're going to put them together. So write x minus 2. We'll just take this stuff, right? We don't need the 0. And then we'll take the second part. We're going to add them, but we're not going to add them, but we're going to put a k. I'm going to put a k there. Let me use a plus k times the second one equals to 0, right? Where k is a number. And we're going to investigate what happens if we substitute different values of k. So we'll combine the two equations and then put a k in front of the second equation. And we're going to substitute different values of k. See what sort of lines we get, right? Okay, all right, let's see. So we're going to investigate what happens when k is equal to 1. So put 1 in there, okay? So it's like adding the two equations together. So we'll put 1 there. X minus 2 plus 1 times the second equation. Now you can just collect like terms. So what do you get? 2x minus y minus 2. We get this new equation that comes from the first two. Because 1 times x is x, x plus x is 2x. Okay? Sorry, I skipped some steps. All right, now we're going to graph it. Now, how do I graph equations? What do we do? What are the techniques you've learned so far? Excellent. Let's find the x and y-intercept. This is the easiest way to draw a graph. Let's find the x-intercept. Now, how do you find x-intercept? You put y equal 0. Thank you. Put y equal to 0. So what do you get? 0, and then you get 2x minus 0 minus 3 is 0. And what do you get? X equal to 1. Thank you. Good. Put 1 there. I'm going to use a different color like green pen. 1. Let's find the y-intercept. What's the y-intercept? That's when x is 0. X is 0, what do you get? So you get negative y minus 2. Notice when 0, just the 2x just disappears, right? So what's y equal to? Negative 2, right? Let's find negative 2. Over here. Now use a ruler, and then miracle could happen. Have a try. And who can tell me what miracle did you see? Where? Where does it? Ah, intersect that. That's why they're in the family, because they're concurrent. That's when k equal to 1. Is it just a fluke? Would it work for -1? Let's try -1. Let's put -1 into the formula. So we've got x minus 2 plus k bracket y x minus 2. No, whoops, y x minus y. Sorry, x minus y equal to 0. So now we're going to substitute k equal to -1. See what happens. K equal to -1. We get a different equation. And let's see what happens. So we get x minus 2 minus x plus y equal to 0. Now what happened to the x term? They cancel. You get a simple equation this time. What do you get? You get y equals to 2, right? What sort of line is this? Well, they're all straight. What do we call that? Horizontal. And what do you see again? They cross through this point again. For k equal to -1. Well, does it work for other numbers? Does it always work? Let's try -2, just in case. Never knew. Maybe that's the odd one out, but you never know. Okay, all right, let's try. Let's put k is -2. All right, that's why it's fun to investigate maths. Okay, so x minus y. All right, -2. All right, let's see what you get. I'll leave the algebra to you and draw the graph and let you see the miracle in your own eyes. Okay, instead of I do it. Yep, all right, let's do it. Okay, all right, I can't be bothered to get rid of the negative. I'll just keep it there. Let's draw the graph. Let's find the x-intercept and the y-intercept. Okay, and then draw it. See what you get. It happened again. Oh my God. Oops. Ignore the pun. Okay. All right. Okay. So what we do is we're going to find x-intercept, and then what do we get for x-intercept? -2 for the x, and then y-intercept is 1, right? Let's do that. Let's see what we get. 1, -2. Y-intercept is 1. X-intercept is -2. If you draw it carefully, alright, it's third time lucky. Okay, I know because the pen's not good. Alright, k equal to, what was that? K was equal to -2. Alright, they all pass through the same point. This is like a, okay, let's try one more time. K equal to 0, that's easy. So what do you get if k is 0? Yeah, so you just get the first equation, isn't it? Because you get 0 here. And so basically the second line gets deleted. So you get x minus 2 is 0. Therefore x equal to 2, which is the original lines that we drew earlier, right? That's where k is 0. You can think of that's where k is 0. All right, so we've got all of this. And now it's easy to fill out the rest. What do you notice? Well, all the lines with the equation of the form, let's write down the equation of the form x minus 2. Actually, let's write it properly. In the form of the one we just wrote, x minus 2 plus k times y minus x minus y equal to 0. This equation must passes through the the same point of section of intersection of the two lines. Yep. Okay, that's pretty good. So now we see what that means when we put a K there. That will lead us to the next section naturally. Now we have a formula for the family of lines through the same point intersection. So basically, let's recap again. So this is like a family. Different K value, you get different, it's like, we call it a family because it's a set of all the lines, right? Family of lines with the property that it must pass through the same point intersection. They're all concurrent. Family lines that are concurrent, if you use the word you just learned, they are concurrent with each other. Okay? And that has a lot of applications, which we'll see later on. Okay, all right, let's try. Let's write down inside the box on the next page. Okay, let's go to the next page. All right, good. So, basically in here, in general, the equation of the line that passes through the point intersection of the lines. So these are the two lines in general form. There has to be in general form. If it passes through if they are concurrent with these two lines, the equation of the family of the line must be a1x plus b1y plus c1 plus the k a2x plus b2y plus c2 equals to 0. Okay? That's the family of lines. Remember, of course, it's a bit more complicated than before because it's a general form, right? So that's the family of lines.
What's that? You printed.
That's a general form, right?
Could you like read out what you printed?
Or a1x, so I've just grabbed this bit. So this bit I copy, put it here. So I take both of these, put it in there, get it? And then I combine them, right? I combine the two equations to generate the family of lines through the same point intersection. Get it? I use the first part, use the second part, put them together. All right, good. And we're going to do this question. Okay. All right. Example 31. Find the equation of the straight line that passes through the point 3, 5. Oh, oops. Oh, no, nothing. Okay, passes through the point 3, 5 and the point intersection of the lines. Okay, now I've already labeled the lines. See, the blue one is the first one. The red one is the second line. We want to find the family of lines through the same point of intersection. You can see on the screen. Okay, so basically these are the family of lines, right? Remember all the lines through the same point? Now how do I construct it? What do? We're going to grab the first bit, grab the second bit, right? So you write x plus y plus 2, and grab the other bit, which is also in general form, put a k there, which linked them together. That's the family of lines. So easy to make a family, right? It's so easy. Say again? It doesn't matter. It doesn't matter. You can put this guy first, put this guy second, and put k there. Get it? Yeah. All right, okay. Okay, so just put it like this. That's the family of lines, right? Now, but only one of them will pass through this point. Only one, right? So let's find that point, 3, 5. All right, let's find 3, 5. Where's 3, 5? Let's find 3, 5. So 3 across, 5 up, which is over here. Can you find that point? 3, 5. So basically, you got this family of lines, which is over here, like all the family of lines which pass through the same point of intersection. So it can be here, it can be there, it could be anywhere, but only one of them will pass through exactly 3, 5. We want to find that equation, right? Now, if you pass through that point, what will happen? I could substitute into the equation, isn't it? And find k. So let's substitute 3, 5 in there. Substitute 3, 5 into above. Right, let's do that. So what do you get? So you get, let's put 3, 5. So put 3, 5, which is 3 into x, 5 into y plus 2, plus k that we're going to find. And then you go 3 minus 5 minus 2. Let's see what we get. And we get 10. And what's that? 3 minus 5 minus 2. Minus 4. Yes, minus 4. Well done. Okay, good. Good job. Okay, now what's k equal to? K equal to 10 over 4, right? I skipped a step because it's pretty easy, which is 2.5, right? Or let's leave it as a fraction. We prefer fraction than decimal. And we prefer the integer than fractions. Okay, so 5 over 2. Yeah, I substitute, right? So I put 3 into x, 5 into y. Okay, good. All right, what do we do? Now we'll sub it back in to get that equation. So we write x plus y plus 2 plus 5 over 2 x minus y minus 2 equal to 0. Now how do I simplify that? We get rid of the fraction. How do I get rid of fraction? Multiply by 2. Cancel. And then you start expanding. So you get 2x plus 2y plus 4 plus 5x minus 5y minus 10 equal to 0. And then you collect like terms, which is 7x minus 3y minus 6 is 0. That's it. We found the line that passed through this 3, 5. And it's part of the same family of the concurrent lines. Okay, so we found it. So this line corresponds to, let me get, so basically this line, exactly this line is the one passed through this point. Okay. All right, any question? So you find k and then find the equation. All right. Now you may wonder, what if I use a different method? Well, I will show you the other method, method 2. Method 2 requires you to find a point intersection. Let's do method 2. There's a hard way. I'll show you the easier way, but I'll show you the hard way second. So the hard way is, you actually find out what that point is first. Well, let's use this way. This way is a little bit easier to understand, but it's longer. So firstly, we'll find a point intersection by elimination. So 1 plus 2, which is 2x, 0. So you get x is 0, right? And once you get x is 0, substitute into 1, so y equal to -2. So we get the 2 point intersection, right? POI. And then what do we do next? This line also passes through the point 3, 5, right? So how do you find the equation of the line? Find the gradient. So write m, gradient of the line. So write m equal to -2 minus 5 over 0 minus 3. 7 over 3, right? And then point gradient form. Y minus y1 equals to 7 over 3, x minus 3, right? And then what do you get? You get 3y minus 15, get rid of the fraction, 7x minus 21. And then you get 7x minus 3y, add the -15 over, that will be -6. As expected, right? Same as before, but can you see this is longer? Well, sort of a bit longer, but maybe shorter because it's easy to solve. What if the equation is harder to solve? No, that's the point we pass through here. So we got this point, which is 0, 2, 0, -2. To find the equation of line, we join these together we get the equation of the line, right? So we need to find the gradient, point gradient form. So I got this point, and then use the point y minus y1 equal to gradient x minus x1. Yeah. So you can do it this way, but I think it's longer if the equation gets more complicated like this. Would the first method be slower with this? It would still take the same amount of steps, right? Okay, good. All right, so we're going to use this family of line business to do the rest of the... So we've got one more page to go through, then we are done. Yeah. Right, 2 more questions, then we're done. 2 more questions. All right, let's move on. Next page. It just says that this method is going to be the same. The first method will still take the same amount of time with this, but if you try to find a point intersection, it's going to take you longer. See, how we got the point intersection, we did it very quick. We just add them. But this one doesn't work by adding. You have to change both equations, then add or subtract, then find x, and then sub it back in to find y. So we take the first step when we find a point intersection, that will take much longer to do. So that's why I prefer you to use method 1 rather than method 2. I just want to show you, want to discuss that. Because some people may find, oh, this method 2, he found it easier to do. So, but it's not always easy because the point intersection can be difficult to find. All right, let's move on to the next page. All right, find the equation of the straight line that passes through the point intersection. Again, family of lines, but it has to be parallel to this line, right? So basically, you got all these family of lines, right? But only one of them will be parallel to the green line. So which is like this. All right, now you see on the board, parallel to this line. You want these two parallel, right? So again, the same thing. We're going to find the equation of the purple line. So you can just combine the two equations. Minus y minus 2, and then you're going to put a k in front, then they're in the same family, right? So this line represents any family of the lines through the same point intersection, but we want the one that is parallel to the green line. Now this is the green line, right? So what's the gradient of this green line? 2, right? If you make y the subject, you get gradients 2. So we want to make sure this gradient is also 2, right? How do you find the gradient? We have to rearrange it. So this requires a little bit more algebra than before. So you go x plus y plus 2 plus kx minus ky minus 2k equal to 0. And then what you need to do is like collect like terms. Like these two are like terms, they both have x. So you write x 1 plus k. Does it make sense? I factorize the x out. X 1 plus k. Next, y 1 minus k. These two. And then finally, plus 2 minus 2k is 0. Now, how do I get the gradient? Make y the subject. So, right, y 1 minus k equals to y 1 minus k equals to negative 1 plus kx minus 2 plus 2k. Right? And then what you need to do is to divide both sides by 1 minus k to get y. No, you don't want to expand it yet. You want to put in that form. Like that. So what do we do? Now I move this to see, I've moved this term to the left, right? That becomes an extra negative, right? That's an x. Let's write it properly. Okay. Numerator is negative 1 plus k in bracket, and then denominator is 1 minus k. 1 minus k. Okay, now remember what was the gradient of the blue line? The purple line? The gradient must be 2 as well, right? So we're going to find a gradient, which is this. This is the gradient. The gradient must equal to 2. Gradient equal to 2. And then what do we do next? Find k. So you go negative 1 plus k equals to times both sides by the denominator. Negative 1 minus k equal to 2 minus 2k. And then what do you get? You get 3 equal to k. K equal to 3. So our aim is to find k. Once you get k, the equation can now be found. Yep, it's long and it's ugly, but let's go through it. Let's put 3 there. So write x minus y. So therefore the equation will be x plus y minus 2 plus the k you found, which is 3. Plus 2, yep. And then the other one is x minus y minus 2 equal to 0. X plus y plus 2 plus 3x minus 3y minus 6 is 0. 4x minus 2y minus 4 is 0. Oh, I have to mark the well. Yeah, mark the well. I'll do that right now. Okay, alright, good. So you get 2x minus y minus 2 is 0. Okay, I'll do that right now. Save this. And then 4. Okay, basically, we found a family of lines through the same point in section, which is that. And we need to find k, but in this case, we'll know this line is parallel to the green line. Parallel to the green line. The green line has gradient 2, therefore we'll find a gradient of the family of the lines, which is also 2, and then found k to be 3. And once you get k equal to 3, sub it back in to find the equation of the line. Okay? Now this is different from the way we did in the first part where you pass through this point. So to find k, you just substitute the point in to find k, which is very easy. Alright, now the good news is, when we do this question again, it's going to be short because we've already done all the hard work. I'm going to copy this over here. Let's write this underneath because it's the same equation. So write y equal negative bracket 1 plus k over 1 minus k x plus negative 2 plus 2k over 1 minus k, right? That's the family of lines through the same point in section because it's the same line. But this time it says it's perpendicular to this line. Perpendicular. Now it's the same line we've got before, isn't it? That gradient is 2. So if they're perpendicular, what do we do? What's the gradient of the purple? Minus half. Yep. So negative half. So it's the negative reciprocal. So therefore I grab the gradient like we did before and solve for k again, but this time put that equal to negative half. Can you see it's very convenient? Once you've done the first part, then you can find k again. So we get, now what I do is you just cross multiply and the negative get cancelled. You get 2 bracket 1 plus k equal to 1 minus k. So the negative gets cancelled, right? Cancel. Right, continuing on, you get 2 plus 2k equal to 1 minus k. Therefore, 3k equal to negative 1. Therefore, k is negative a third. So when k is negative a third, it gives you the particular line that pass through the point of section perpendicular to the green line. Okay. All right. Can you find the equation of the line now? Because I know what k is. Equation of the line is now easy. See this one. That's when k equal to 3. K equal to 3. let's continue. So what do? So put negative a third into the equation, which is x plus 2, keep writing x plus 2, x plus y plus 2, and then the other one is x minus y minus 2, right? But we found k to be negative a third equal to 0. So that's the equation of the purple line. We'll try to find the equation of this. And like before, get rid of the fraction. So multiply both sides by 3. And that will cancel the denominator. Expand. 3x plus 3y plus 6 minus x plus y plus 2 equal to 0. And then we collect like terms. 2x plus 4y plus 8 equal to 0. X plus 2y plus 4 is 0. We found it. That's the line perpendicular to the first one. Why is it minus a third? Because I solved it here, right? So we'll make the gradient equal to negative half. See the one before, we make the gradient equal to 2. This time make it equal to negative half. Yeah. And then we solve it. And k is negative a third. This is very good. I thought you would get confused, but you all understood. I was very impressed with your performance. Okay, right. So you can now do the work now from the exercise 7.7 today.